All right, so let's add this page into your notes about interpolation, because what if it's asking you for a number that's not exactly precisely on our property tables? For instance, how about this question? What is the enthalpy of saturated liquid water at 92 degrees Celsius? All right, so first of all, I know it's SI units because 92 degrees. I know that it is water, so I'm in tables 4, 5, 6, 7. I know it is saturated, so I'm in tables 4 or 5, and I'm at, they give me a temperature, so I know I'm at table 4, A4. Right? So I go to table A4 and look at table A4, and we've got a line for 90 degrees C. We've got a line for 95 degrees C. But the question is asking for 92 degrees C. What do I do? Well, you have to interpolate. You have to say, okay, well, it's going to be, if my temperature is in between these two values, then my enthalpy is going to have to be in between these two values. Is it going to be closer to this one or closer to this one? Well, is 92 degrees closer to 90 or 95? It's going to be a little bit closer to 95. And so we can assume that there's a linear line between property values. It isn't always exactly linear, but we can assume, it's a good assumption at these small increments, that these are linear lines between the property values. And so if we know this point down here at 90 degrees is 37.7, then this point right here at 95 degrees is 398.09, and then we're just trying to find, okay, so what is this value right here? You could do like similar triangles. And I used to kind of teach that as well, that blue triangle is similar to this pink triangle. So if you look at the bases and heights of those, you could find the this base of the blue triangle, actually the height of the blue triangle. Or you can interpolate, and I do not mind if your calculator does the interpolation for you, but here's how I do it. I take the top minus bottom over middle minus bottom. That's what I've got here. I take the temperature, the top minus bottom over middle minus bottom, and this is really similar triangles, is what interpolation is equal to the top minus bottom over middle minus bottom. I'm sorry, I've kind of got these backwards, and actually it doesn't matter if you do them backwards because it's really a ratio. All right, so but what I do, here we go. Top minus bottom over middle minus bottom is equal to top minus bottom over middle minus bottom. Do you see that? Here's the top minus bottom over middle minus bottom is equal to the top minus bottom over middle minus bottom of the other axis. Do you see what I'm doing? I'm saying that this length divided by that length is the same ratio as this length divided by that length. Let me do a different color. Divided by that length. All right, that's what interpolation is. It's saying that this black line divided by the blue line is equal to this green line divided by the pink line. Now, because this is two fractions that are equal to each other, it's okay if you flip both sides of the equations, right? It's okay if you flip both sides of the equations and you say this blue line divided by the black line is equal to the pink line divided by the green line, all right? Or you could say blue divided by green equals, black divided by green equals blue divided by pink. You have to stay consistent. Here's the thing that I do just to make sure. This is what I do right here. The left-hand side of my equation, I just make sure that corresponds with that. This temperature corresponds with this enthalpy. And that's that, we'll call it a blue dot right here. right? I make sure that this temperature corresponds with this enthalpy, and it's again right here and here. And then lastly, make sure that that temperature corresponds with that one right there. Do you see that? And I'm probably making this more complicated than it is. And some of you might just use interpolation in your calculator. It's really kind of a weighted average, similar triangles. The ratios of one are equal to the ratios of another. All right? Maybe Google it. Make sure you can do this. And make sure your answer makes sense. Okay, first of all, your answer better be in between these two values. I've seen way too many students who would give me an answer that say my answer is 400 something, or even worse, they'd say my answer is 24.3 or something, something like that. Make sure your answer is in between the two, and you should be able to tell if this is 92, it needs to be closer to 377 than it is to 398. It needs to be closer to 377 because 92 is closer to 90 than it is to 95. All right, you've got to be able to interpolate, and you got to kind of be able to do it pretty fast and quickly because that's not the big part of the problem. The big part of the problem is like taking this, and using it, multiplying it times the mass, or if this was volume, specific volume, taking that, multiplying it times, the mass to get the total volume, things like that. All right, so that was a not a great explanation of interpolation, and it's really just back to high school. If you know this point right here, and you know this point, okay, yeah, just go back to high school and think about it. If you know these 2 points on a line, and you know the x-coordinate of this point, what is the y-coordinate of that point? That is what interpolation is. That is what interpolation is. And you might see it explained a little bit differently, maybe calculating the slope here. I'm gonna do top minus bottom over middle minus bottom equals top minus bottom over middle minus bottom. That's how I do it. That's how you're going to see me do these problems.